Hello and welcome to 16.2 Formal Charge. We're going to start off today by saying, how do we know which of these structures is correct? You might think that one of them looks obviously right, but if you count the number of electrons, each one, all of the atoms are satisfied. They all have 8. This one here, 1, 2, 3, 4, 5, 6, 7, 8. The carbon has 8. Even over here, the carbon has 8, even if it has lots of valence electrons. So, how do you know which structure is correct? Well, in the previous videos, when we talked about how to draw Lewis structures, if you follow the instructions that we told you to do, like the order of steps, you should draw the correct one by going through it like that. But there's also a way to determine it mathematically, and that is what we call the formal charge. So the formal charge is an equation, which is the number of valence electrons minus half the number of bonding electrons minus the number of non-bonding electrons. And each atom in a compound has its own formal charge. If there are multiple possible Lewis structures, the most reasonable one will be the one where has a formal charge difference closest to 0. And the formal charge difference is the atom that has the highest formal charge minus the atom that has the lowest formal charge. And it will also be the one that has the negative charges located on the most electronegative atoms. So here's an example. This is boron tetrafluoride. There's two ways this could be drawn. Like this, where boron has 6 valence electrons, and has 6 total electrons, and each of the fluorine has single bonded to the boron, and they have 8 electrons. Or there could be this one here, where all the fluorines have 8 electrons. This fluorine has a double bond, and then that makes boron have 8 electrons as well. This would be how you would draw it according to the rules, because boron, you would want to give it 8 electrons. But we can use formal charge to make sure that that is the case. So in this case, we calculate the formal charge of boron. It's equal to the number of valence electrons boron has, which is 3, minus half the number of bonded electrons in boron, which is 6, because it has 3 single bonds, and then minus the free electron, like the non-bonded electrons it has, which is none. So in total, that gives us a charge of 0. Then the charge of all these fluorines is the same, because they are all the exact same to each other in comparison to their bonds. So the formal charge of the fluorines is 7 minus half of the 2 bonded electrons they each have, minus the 6 non-bonded electrons they have, which also gives us 0. So that tells us that their difference in formal charge is 0 minus 0, which is equal to 0. Then we look at this one, and this case, boron has its formal charge is 3, because it has 3 valence electrons, minus half of 8, because it has 8 bonded electrons, minus 0. That gives us a formal charge of negative 1. Then we have the fluorine that isn't double bonded, so these two fluorines, this is their formal charge. It is they have 7 valence electrons, minus half of 2, because they have 1 bond, minus 6, that gives us 0, same as in the other one. And then we have the double bonded fluorine, so that has 7 valence electrons, minus half of 4, because it has a double bond here, minus 4, because it then has 4 non-bonded electrons, and that gives us a formal charge of 1. So if we find the difference in their formal charge, it will be the highest formal charge, which in this case is 1, minus the minimum, the lowest formal charge, which is -1. So that gives us 1 minus -1 and 2. So If we looked back on what we said is the most reasonable structure, it should be the one that has a difference of formal charge closest to zero. And in this case, it's actually this one here, where boron only has 6 electrons. All right. Let us go back to the question that started this. How do I know which of these carbon dioxide molecules is correct? Which one's drawn properly? I will give you a chance to pause right now and do this for yourself. It will be good practice. All right? Okay. I'm now going to give the answer here, go through the answer. This oxygen has a formal charge of 1, this carbon has a formal charge of 0, and this oxygen has a formal charge of -1. So their difference in formal charge is 2. The second one, this oxygen has a formal charge of 0, this carbon has a formal charge of 0, and this oxygen has a formal charge of 0. That gives us a difference of 0. And finally, this one has a formal charge of 0, 2, and -2, which gives us a formal charge of 4. So which structure is correct? It is this center one here, because it has a formal charge closest to 0. All right, do some practice on formal charges. And that is the end of this video. Thank you guys so much for listening.